So in one of our videos with the difference of squares and cubes and all that, I was saying that the factored form is they are conjugates of each other. A complex number is a number with both real and imaginary parts, such as a plus bi. So when you have a fraction with an I or a square root, you want to get rid of all the weird stuff at the bottom for the denominator. So to move all that stuff and change them into just regular real numbers and rational numbers on top of that, we will multiply by the conjugate. Now we have a specific desired conjugate that we want, and that will be, we will only change the sign of the number that has an I or a radical in it. So we're not going to change 3, we're just going to change the 7i part. So for this example, the desired conjugate of 3 plus 7i is 3 minus 7i. So you'll multiply the top and bottom by 3 minus 7i, and then if you recall your sum of squares, we multiply these together and get a squared plus b squared. So 3 times 3 is 9, and 7i times negative 7i is 49. Because remember, I times I is negative 1, so it makes the negative cancel out. For your inner and outer, where you're doing the FOIL, they will cancel out. You'll basically have 21i minus 21i. That's why there's no middle term. Now at the top in your numerator, you still need to multiply by that conjugate. So 5 times 3 is 15, and 5 times negative 7i is negative 35i. So after you add the denominator together to get one number, your rationalized form is 15 minus 35i divided by 58. Again, when you have denominators, the denominator is basically the name of our fraction, and we want our names to be very simple without the i's or the radicals or anything like that. We just want a rational number at the bottom. So this would be our rationalized form. So let's go ahead and find out what's the desired conjugate of these following binomials. So again, we're just going to change the sign that is in front of either the square root term or the I term. So for this one, they reordered it, but we still changed the sign in front of that term. So it will be negative square root of 5 plus 1. So even if they reorder it, the one that you change the sign for is, again, going to be the square root or the I part. So go ahead, pause the video, and see if you can find what the conjugate of this one is. The conjugate of negative 3i plus 7x is 3i plus 7x. Again, we only changed the sign in front of the I part. Okay, pause the video, see if you can find the conjugate of this last one, 4 plus 9i. The conjugate of 4 plus 9i is 4 minus 9i. Okay, now we're going to apply this with some examples on rationalizing our fractions. So, on the first one, think about what our desired conjugate is for 2 plus 3i, and you'll multiply that. The conjugate of that is 2 minus 3i. So you're going to multiply the top and the bottom by 2 minus 3i. Again, you use your sum of squares for the bottom part, Or you could FOIL or box method it out, whichever way you feel most confident with. So you have 4 plus 9 at the bottom. And at the top, you have 2 times 2 is 4, and 2 times negative 3i is negative 6i. Now we're not quite done. We want to add the 2 numbers in the denominator. So we have 4 minus 6i, and then over 13. That is our rationalized fraction. We have a simple number at the bottom, a real rational number, and at the top, now that's where you could have some other complex stuff. Okay, so go ahead and pause the video, see if you could do the next one by yourself. Okay, so the desired conjugate that we want here is 3x plus 4i. And again, whatever we do to the bottom, we have to do to the top. So we're going to multiply the numerator also by 3x plus 4i. So again, use your sum of squares to find the bottom. That's going to be 9x squared and then plus 16. And then at the top, again, use your FOIL or box method. You'll have 3x squared plus 4xi and plus 3x plus 4i. So if you look at this, it looks like there are no terms to actually combine, so that is your answer. Okay, pause the video, see if you can figure out the last one. You can find the conjugate of the denominator, rationalize it. Okay, the desired conjugate of x minus square root of 5 is x plus the square root of 5. And then you'll multiply that by the numerator as well, x plus square root of 5. And then we have x plus the square root of 5. And then remember our difference of squares this time. We have x squared minus 5. Again, this is going to be difference of squares because we do not have an I in it. So there will be no I squared to cancel out the negatives. So that's why there's still a negative that remains here. Square root of 5 times square root of 5 is 5. Okay, notice there's nothing else that you could combine for like terms. So you're done with, and this is your answer.